notice that the tone changed as we run by. The tone changed as a result of change in frequency. And as the sound source moves towards the observer, the sound waves compresses and generates a higher frequency, which the observer perceives as a higher pitched tone than the source emits. As the sound source passes by the observer and becomes more distant, the frequency is perceived as a lower pitched tone instead.
This phenomenon, known as the Doppler effect, describes the changes in frequency between a sound source in motion in relation to an observer. Let's watch as our stuntman demonstrates the Doppler effect in reality.
En person som befinner sig i Sverige får använda sig av rättegångsbalkens regler som säger att man får gripa folk som gör sig skyldiga till brott. Men då ska det vara när man gör sig skyldig till brott. Att köra omkring och leta upp någon man tror har gjort brott, det är absolut förbjudet och det är i högsta grad olämpligt.
Vi ska ta han och ta hans familj och ta hans namn, efternamn, samma efternamn till han. Alla på en gång de ska dö.
Får vi tag på lasermannen ska han dö. Garanti. Ja, de är ute efter lasermannen nu.
To clarify what our professional stuntman was demonstrating, we have these following pictures for a more academic explanation.
This is when the source and the receiver are both standing still. This means that the sound waves will be registered by the receiver with the same frequency as transmitted.
In this picture, we have two different scenarios. In the first scenario is when the sound source moves towards the observer. The sound waves compress as the source moves with the sound. And the distance between the waves decreases. This generates a higher pitched tone for the observer.
In the other case, when the observer is behind the source, the distance between the sound waves increases and the frequency becomes slower. In contrast, this generates a lower pitched tone for the observer.
Yeah.
And now, fun facts with David.
Hello children, did you know that when the sound source moves faster than the speed of the sound, then a phenomenon known as a sonic boom occurs? The cause of this phenomenon is that when an object passes through the air, it creates a series of pressure waves, both in front and behind it. The pressure waves travel at the speed of sound, and as the speed of the object increases, the air waves compress. When the source moves as fast or faster than the speed of sound, the air waves merge into a single shock wave. This shock wave, made out of air waves, creates a huge difference in pressure between the shock wave and the normal air, which results in a huge boom called a sonic boom. That's all for us. See you next time. Boom out!
Du bara kör på lite.
Kör någon move.
Det spelar ingen roll om det är något ljud eller någonting. Det kommer lägga in efter dig. Ja, det gör det så här.
Räcker inte det eller? In i kameran. 1, 2, så det där.
1, 2, alla går såhär, står på tur.
For a more academic explanation. Picture, we have two different scenarios.
Säg till innan du börjar.
In this picture, we have two different scenarios.
Men kör ändå.
Det här var ju en äkta bra.
Ja, nu kör vi! Okej.
Ja, men jag håller det så här.
Man måste köra så här snabbt.
Ja, jag vet hur man tar upp den.
Men du måste gå ner igen.
Ja, men...
Hi.
Hi.
That's all for us. See you next time. Boom out!